Hello, everyone. My name is Zhang Horan and I am a master's student at East China Normal University. The title of my paper is Invariant Adversarial Imitation Learning from Visual Inputs. It is my pleasure to present my research at ICASSP2023 and share my findings with you. Imitation learning has shown tremendous success in a wide range of areas, including healthcare, robotic manipulation, and gaming. However, when dealing with visual observations, existing IL approaches often learn policies that do not generalize to environments different than those the agent was trained on, even when these environments are semantically equivalent. For instance, when performing an autonomous driving assignment, even when following the same route, variable lighting conditions may cause agents to make a completely different decision, which might result in mission failure. In this paper, we propose an invariant model-based adversarial imitation learning approach to improve the generalization of agents in visual control tasks. The following is the general framework of our method. On the left, IMAIL constructs a world model of POMDPs that learns belief representations BT from history using the encoder E in a GRU cell. Furthermore, their prior is determined from the transition model. It gives a wealth of auxiliary objectives to help speed up the representation learning process. Following that, we impose mutual information constraints on the latent belief representations, rendering the representations insensitive to environmental changes. Finally, on the framework's right side, we use GAIL to learn generalizable policies based on invariant belief representations. Our main contributions can be summarized to the following 2 points. The world model we use is similar to Planet and Dreamer. The difference is that we remove the reward prediction model to introduce it into the IL setting. As a result, the world model constructed by IMAIL is comprised of the following modules. These 3 models are optimized jointly to increase the variational lower bound as follows. To achieve the goal of learning invariant belief representations, we decompose the observations X into 2 components. Task-relevant features C and noise terms eta. The task-relevant features are captured by the representation model and used to construct belief representations. The noise terms representations are also learned to provide environment-specific information, allowing for the reconstruction of observations from different environments. Then equation 1 can be extended to optimize as follows. To separate these 2 components, we impose 2 different mutual information constraints to regularize the latent representations. The first is for the belief representations. We propose to minimize the estimated mutual information between the belief representations and the corresponding environment labels. Thus, the belief representations can only contain the historical information of task-relevant features, excluding features varying with environments. The second is for the noise representations, which make the noise terms in different environments independent of each other. We use the MIND framework to construct our estimator and the learning goals are as follows. We conduct experiments on image-based continuous controlled tasks of the distracting DM control suite and the Robol platform. The experimental results are shown on the left. The first row shows the learning curves of each method tackling controlled tasks in the default environments. The second row shows the performance of each approach in test environments during the training time. We can see that, in the distractors setting, only IMAIL stably achieves expert-level performance and generalizes well across different environments. Further ablation experiments are described in our paper if you are interested. Here are more experimental results of IMAIL in test environments. Thank you for your listening.